when we were looking at the standardized curve, we were dealing with a mean of 0, standard deviation of 1. Okay, so this is called the standard normal bell curve. And in this, we can also use normal tools in the calculator to find probability. So looking at example 5, here part A asks to find the probability that z is less than negative 1.5. Okay, so because we're looking at z, we're looking at the standardized curve. Okay, and the standardized curve is centered at 0, and I need to place negative 1.5 on that number line. So if this was a number line centered at 0, negative 1.5 should go somewhere here. And notice if z is less than that number, if we want to be less, we need to shade this way. So in order to find that area there, the probability that z is less than negative 1.5, area under the curve, the setup is normal CDF. Once again, we need 4 entries for the normal CDF. So we need lower bound, upper bound, mean, and sigma in order to find the area. So here we need normal CDF. And what's the lowest that the shaded region goes on the number line? It goes to negative infinity. So we'll use negative E99 to represent. And then we need the upper bound. We need to see the highest that the shaded region goes on the number line. The highest it goes is negative 1.5. Because we're dealing with the standardized normal curve, the mean is 0 and the standard deviation is 1. So in the calculator, we'll go ahead and fill in these accordingly. Okay. So we have second vars, normal CDF. Okay. So the lower bound, I'm going to go ahead and type in negative E99. The upper bound is negative 1.5. The mean, standardized 0. The spread, standardized 1. Okay. So the proportion or the area that's shaded underneath the standard normal curve is 0.0668. And for the rest of example 5, it'll be very similar. Okay, so let's look at part B. Okay. So for part B, we're looking to find the probability that z is greater than 1.5. Okay. So on a bell curve, which is standardized, that means we're centered at 0, and we need to place 1.5 somewhere on the number line. So because we are centered at 0, 1.5 should go somewhere on this side here. And notice we want to be greater than the 1.5, so we shade this way. That gives us our lower bound, upper bound, mean, standard deviation. So the probability that z is bigger than 1.5, that's going to be a normal CDF. Lower bound, the lowest it goes on the number line, 1.5. The highest the shaded region goes on the number line, this time it does go to infinity. The mean, sigma, when standardized, 0, 1. So now we'll go to second vars, normal CDF. This time our lower bound is 1.5. The upper bound is E99. The mean, spread, standardized. And you'll notice something with these two examples, we got the same answer, right? So what happens is the normal distribution, we're dealing with a symmetric bell curve. And then when you're centered at 0, you have symmetry on both sides, right? On both sides. So if you're dealing with 1.5 shaded to the right, negative 1.5 shaded to the left, those two tails have the same area. So by symmetry, we should be able to get the same answer. For part C will be very similar to what we've done before. So this one will ask for area in between. Okay. So to find the area between negative 1.5 and 1.5, we have our bell curve. Okay. Once again, we're centered at 0, and we would like to place negative 1.5 and the 1.5 on the bell curve. So negative 1.5 should be on this side, positive 1.5 should be on this side, and we want to find the area between. Several ways to find this. We're going to go ahead and continue the way we've been using the calculator. So we need lower bound, upper bound, which we have, mean, and sigma. So the probability that we are between negative 1.5 and 1.5, okay, that's a normal CDF. The lower bound, the lowest the shaded region goes, negative 1.5 on the number line. The highest that the shaded region goes on the number line is 1.5. The mean, standardized. Sigma, standardized. Okay. So in the calculator, let's go to second bars, normal CDF, lower bound, negative 1.5, upper bound, 1.5, and then we're dealing with the Z curve. So the area in between, 0.8663.